Hi, welcome to my channel. In this video, we want to solve the following problem. Given a particle located at the origin, let F1, which equals minus 12x hat plus gy hat, be a force acting on the particle at an angle of theta above the negative x-axis. F2, which equals 15x hat, be a second force acting along the positive x-axis. And F3, which equals minus 3x hat minus gy hat, be a third force acting on a particle at an angle of 2 theta below the negative x-axis. Given that g is a constant, our goal is to find the magnitude of the force F3. And now for the solution. First, let's express the forces in terms of their magnitudes and directions. Thus, F1 equals minus square root 144 plus g square cosine theta s hat plus square root 144 plus g square sine theta y hat. And F3 equals minus square root 9 plus g square cosine 2 theta s hat minus square root 9 plus g square sine 2 theta y hat. Now, the resultant force, which is the sum of the three forces, is equivalent to 0, and this implies that the particle is in equilibrium. Writing the forces in terms of their magnitudes and directions, this means that the components along x and y are 0. That is, we have minus square root 144 plus g square cosine theta plus 15 minus square root 9 plus g square cosine 2 theta equals 0. And square root 144 plus g square sine theta minus square root 9 plus g square sine 2 theta equals 0. In the second equation, we write sine 2 theta as 2 sine theta cosine theta. Sine theta cancels out, and after rearranging, we obtain cosine theta equals square root 144 plus g square over 2 times square root 9 plus g square. In the first equation, we write cosine 2 theta as 2 times cosine theta square minus 1. And then substitute the expression for cosine theta to obtain this lengthy expression, which simplifies to the equation minus 144 plus g square over square root 9 plus g square plus 15 plus square root 9 plus g square equals 0. Multiplying both sides by square root 9 plus g square to clear the denominator, we see that g square cancels out, and after rearranging, we obtain 15 square root 9 plus g square equals 135. Therefore, F3 equals 9 units, which is the solution to our problem. Alternatively, we can use geometry to solve our problem. Returning to our diagram, since the resultant force is 0, using the tip-to-tail method to rearrange the vectors, we'll end up with a closed triangle. Labeling the vertices as A, B, and C, the sides of triangle ABC thus equal the magnitude of the forces. To determine the parameters of the triangle, from A, draw a perpendicular to BC at D. The length of BD equals the magnitude of the x component of F3, and thus equals 3 units. The length of CD equals the magnitude of the x component of F1, and thus equals 12 units, while the length of AB equals F3. To solve for F3, from A, draw a line intersecting CD at E and such that angle BEA equals 2 theta. Therefore, triangle ABE is an isosceles triangle. The length of AE thus equals F32. AD, which is the height of the triangle, thus bisects BE. The length of DE therefore equals 3 units, while the length of CE equals 12 minus 3, or 9 units. Now, angle BEA is also an exterior angle of triangle AEC. Since an exterior angle equals the sum of interior opposite angles. Angle CAE equals 2 theta minus theta, or theta. Thus, triangle AEC is an isosceles triangle. Therefore, we have AE equals EC, or F3 equals 9 units, corroborating our previous result. For this problem, the geometric approach appears relatively simpler compared to the trigonometric method. By visualizing forces as a closed polygon, we can use powerful geometrical methods. When trigonometric approaches get complex, a geometrical approach might provide a valuable alternative. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.